sometimes when we are working with these numbers, we can end up with a positive mantissa and a negative exponent. So if I give you this example here, what we've got is 0.11, and we're going to go 0. So we're going to go for, again, a 12-bit number with an 8-bit mantissa and a 4-bit exponent. So we're going to go for this again. So 0, 1, 1, 0. And we're going to pad that out so it's 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Then this time, because we're working in 2's complement, we're going to have our exponent here. But what you'll notice that we end up with is we've got -8, 4, 2, 1. We know that this, because -8 plus 4 plus the 1, this gives us an exponent which is 2 to the power of -3. So this is a -3. This is different. We've not came across this yet. So this decimal point, again, when it's normalized, it starts here. All right. Now this decimal point starts here, but what this means now, because we're going -3, all right, we are going to need to pad this out to put in the decimal places. So what you're essentially going to end up with is you're going to end up moving this that way this time. All right. So what you're going to end up with is I'm going to pad it with 3 zeros. So we're going to go 0. All right. 0, 0. So then I'm going to write the rest of the number out until I get up to 12. So 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what's actually happened is you don't necessarily move the decimal place. You're padding it, but the decimal place stays in the same location. I hope that makes sense. All right. So basically what this number has ended up with is you've got your half, your quarter, your eighth, your 16th, and your 32, and so on. All right. So what you've got there is, if you work that number out slightly, so we've got this one would be 0.0625, and this one would be 0.03125, and if you add that together, you end up with 0.09375. All right. Because each of these values have a decimal, so I've worked out what each of those are, and we've added those together, and that gave you your final number, which should be 0.09375. We are going to go on to, all right, how we can work out a negative mantissa and positive exponent. So we're going to go on to this in our next video.